Good afternoon, everybody. My name is Min John from Momentum Learning in Houston, Texas. This is our open session to review the past round of USACO contest in December 2022. It is our tradition to hold the review sessions during the contest season. So this is the first one for December round review, and we're also going to do that one for the Jan round, Feb round, and also the March round for US Open. Thanks for coming. Today, for the first hour, we're going to review the 3 questions in the bronze level contest, the bronze contest review. The 3 questions in the December round from the feedback of many students who took the contest saying, the difficult level actually was in line with the 2021-2022 seasons, compared with problems in the previous seasons, like from 2016, 17, 18, it is harder. The difficulty level is harder than those years when platinum was added to the contest. So it is getting harder. And also the number of the participants, look at this one, right, the number here. So for one round, just in the bronze level, that's more than 10,000. As many of you have known this one, I've been keeping track of the number, the total number of participants. Years ago, the 4 rounds, all the 4 levels actually would add up to 10,000. And now just 1 round and 1 level bronze, this number is above 10,000. So the number is getting bigger and bigger. You can check if you're interested, right? This number is always there for you to track. So it is getting more popular, and it is getting, I think, more challenge. So what is the best time to participate? Now. It's always the case. In the next 5-10 years, this number would get even bigger and bigger. Okay, so let's look at the first question. We try to cover the 3 questions here in the 1 hour. Depends. In the middle of the session, you can ask me questions. I'll try to answer as much as I can. So we can see if we can finish all 3, that's great. If we cannot, that's also fine. All right, so let's look at the first question. The recording would be stored at Zoom Cloud, and we would give you the link later, right? You would get the link later on. For all the people who have registered, you would get an email notice saying, give me the link to the Zoom Cloud. What that the schools tell us? Well, the schools will only tell us the passing threshold. So in general, the passing threshold is 750 out of the 1,000 total score. So if you want to get the promotion, you need to get 75% of the credits. So it's actually not that high. Just like to get the 5 in AP test, right? You don't have to get 100% correct or 90% correct. So 75% of the partial, the credits, then you would get the promotion. Of course, if you do get a higher score, then you would also feel better. All right, okay, so let's still go to the first question, Cal College. So in this question, we are given an array of integers. N is at most 100,000. So again, as I've told many of you in our classes, if you see at bronze level, the input size goes to 10.5, then do not go panic. Actually, you would kind of feel happy. There must be an easy way to solve the problem without running the loop with 2 or more layers. So here, for those right not familiar with the jargon, when I say a layer, you have a loop here, and inside you have another one nested, right? So we say here this would be a layer, would be a loop of 2 layers. You have the out layer and the inner layer. So if you have n goes to 10.5, you cannot afford to run a loop of 2 layers, right? So there's a loop variable I, there's loop variable j. Either j and I would be independent or j dependent on I. For example, right, j would always be bigger than I, or j may be always less than I, but still there will be 2 layers, and that will run roughly n squared number of iterations, and that will be out of time. You're going to run out of time. So for this one, you know you don't have to write a loop with 2 layers or more. So very likely you should be able to solve the question with just 1 layer. Okay, so now we're given n numbers. Each number is an integer in the range from 1 through a million. So that is the price each student is willing to pay for college. Each one is willing to pay this one if the college tuition is no more than their price they can afford. If the price is bigger, then they cannot attend college. So our job is to find out what is the maximum tuition FJ can connect. So here the number of the amount of the tuition connected, right, would be the number of students times the tuition level. So you can see easily, right? I do have to try each T and then try all the students, how many can afford to pay this tuition level. And for the T, since all the numbers are in the range, right, between 1 and a million, do I have to try every value for the T? Think about it. Actually, you don't have to try all the 1 million possible tuition charge. Why? Because if the tuition is T here, and then there is the value, say CI here, and then the next C, for example, CI plus 1, the next value that is bigger than CI, do you think this T would make it better than the CI put it here? Or do you think, right, all these guys will make any difference? If we say CI is here, the next number in the array, CI plus 1, is the smallest one that is bigger than CI. If FJ is charging the tuition here, or charging tuition here, or here, do you think it will make it better than the charging the tuition here? Because, right, if the tuition T is here, all these guys, they cannot afford, so they cannot attend, so they will not pay. But for all those, if their price, the level, right, is above T, they can afford to pay it. So why don't we just say charge the tuition at CI plus 1? And still the number of people, right, can afford to pay the tuition actually would be the same. So we don't have to try all the values between CI and CI plus 1 exclusively, right? You don't have to try them. You just need to try those numbers from the array. So we don't have tried the 10, 6, or a million possible values for the tuition level. Okay, that will reduce the number of the values we have to check. And then the another one is, I still need to make sure I can get the count, how many people, how many cows, right, can afford this tuition level T. Remember, right, I cannot afford to write a loop with 2 layers. Even though this one I can reduce from 10.6 to 10.5, still n can go up to 10.5. If I have to check each cow, if you give me the tuition level, right, try each one here, that will run another layer. That's also 10.5, that's still too big. So I want to be able to count. If you tell me the price level, how many cows can afford this price, can I do this counting faster rather than doing it one by one? So the intuitive way, right? Give me the tuition level for each cow, check whether you can afford this one, right? Check whether this, suppose this is our input array A, run another layer of the loop, say, okay, hey, cow 1, can you afford T? If you can, add count by 1. Count 2, can you afford it? Count 3, and so on, right? So that's another layer. We don't want to run that second layer. Can we do this one faster? So here we can do a sorting. We can sort the array A at the very beginning. Right after we read the input, we're going to sort the numbers. So if we have sorted the array A, then this counting is much easier. Why? Okay, suppose we have sorted the array A here. Now we're going to use AI here, AI plus 1. So if you say my tuition level is here, everybody after AI, they can afford the tuition, right? Everybody before they can't. So now if I say from this is position 1, A1 here, A2, all the way through AI minus 1, all these they cannot afford, so they cannot contribute to the amount FJ can collect. So from I to the end, so we can do N minus I and plus 1, right? Going from position I to position N here, all these people, they can afford, so they can pay the tuition. So the counting would be easier, N minus I minus 1, or only those right from 1 through I minus 1, they cannot afford. So you're going to do N minus I minus 1. Those cannot afford. So that's the same as N minus I plus 1. So now the counting will be done just one operation rather than running a loop. I don't need a loop. So still I'm going to run a loop with one layer. So try all the different tuition levels. Again, tuition levels, rather than checking all the 1 million numbers, I'll just check the values in the array. So that's at most 10, 5, 100,000 iterations. For each T, the number of the people can afford is this number here. So this times the value AI, right? I'm going to choose the tuition level as AI, and N minus I plus 1 people can afford this price. So this is the tuition, total tuition FJ can collect. So we're going to see whether this value will make the record higher. So we're going to have a max tuition, max value. This is a record FJ can collect. If this number is big than this max value record, I'm going to update it. And also remember, right, what is the tuition that we're going to charge? And another scenario is if this one is not big than the record, but the T is smaller, then we're going to also update, because here it will say display the maximum amount FJ can collect. And also if there are multiple solutions, display the smallest tuition. So if the value collected is tied to the record, but the value T is smaller, we still have to update the T. So at the end, we're going to just report the max value and also the minimum T. If we have multiple choices of the tuition charged, but resulted the same max amount of the total value collected. So report that max value and then also the minimum tuition. So let me go through the implementation. Hopefully that will make it easier for you to follow. So here, I'm going to go through the both versions in Java and C++. And that's the number of the integers, or number of the counts or students. And we're going to read the input. So each person can afford to pay AI amount. Why I want to make this one long? Because later I want to do the multiplication. So 10,6 times the number of people who can pay for it, right? So this can go bigger than, go beyond the range of integers. So I want to change the declaration from int typical to long. Even though this one is an integer, right? I can still read it as a long. But this one actually you can read next long or next integer, should be fine. And this is important. I'm going to sort all the numbers in array A in ascending order. And this is the answer we're going to report, the maximum profit and also the best tuition level. Here, best means minimum tuition level while achieving the maximum profit. Now we're going to go from the end. Actually, you can either way, it's fine. You can go from the smallest one to the biggest one, the tuition level charged. So when we go through now through n-1 to 0 here, AJ would be the tuition level, right? If tuition charged is just AJ, how many people can afford to pay this one from J to n-1? So this is 0 indexed. So going from J all the way through n-1. If you want to count how many integers in this range, right, inclusive. So this number n-1 minus J plus 1. When you try to count the number of integers in the range, you have to plus 1 here. So that's n minus J. Each person will pay AJ here. So that's the amount, the profit, P. If this P is big, then the record here, we're going to update the record and also update the T. If P is tied to the record, but AJ, the new tuition, is less than the tuition record here, we're going to also update T. You don't have to update the maximum profit because it's still the same. So when this is done, when the loop is done, n iterations, then we have the maximum profit and also the best tuition level. And we just print out the two and then we're done. Okay, so this is the Java version, and I can show you the C++ version, pretty much the same. So here again, n, that's the number of students or integers or cows here, and read all of them. Again, I'm going to declare them as long integers, sort them in ascending order. And an answer is maximum profit, T is the best tuition. And this part, if you write in Java and C++, this part is the same, exactly the same, no change at all. And at the end, just print out the maximum profit, and also the best tuition, and then we're done. Okay, so let me go through some of the messages here. Okay, so if you can score 800, then of course you would pass this pass round. In general, almost all the times, if you can score 800 or above, then you should pass. Except there's one round, the passing threshold for bronze was 850 because one question, you only need to reply yes or no. So you would get half of the credit for that problem. So that's why they raise the passing threshold. So except that round, I think that's March 2019. But all other rounds, the passing threshold actually was low higher than 750. So, right. But that will not happen anymore. So if a question, it will ask you to report yes or no. Now I think the common practice is they're going to give you the multiple test cases or multiple queries for each test case. And you need to report how many queries you can answer yes. Or you're going to report, this is particularly popular for bronze. So you're given Q queries. So for each query, you're going to answer 1 for yes and 0 for no. So you can report a binary number. Right, since Q, normally, right, we're going to say no more than 20. So you can report a binary string of size up to 20. Each one is 1 or 0. And for some of you have taken the momentum class in the past semester, we have done this also. So to prevent you from just guessing yes or no, right? So you have 50% of chance to get it right. So we're going to have, say, give you the number of queries. For each one, you're going to put a 1 or 0. So that's a binary number. And you can easily convert this one into a number in base 10. So still, it will be the same as the difficulty level does not increase, but now you cannot guess. So after that round, so it's almost guaranteed you're not going to have that luck. So just guess, and if you don't get 50% of the credit, just change your answer to no. Then it's guaranteed, right? You're going to get at least 50%. The good days are gone. Okay, so that is for question 1. Now question 2, feeding the cows. All right, so let me go through the question briefly. We have, this time we have the queries. I don't want to use the say T for test cases because we do have the input and we call each input a test case. So normally I call these queries. So we have T or Q queries inside here. So in this question, you have Q can go up to 10 queries. So for each query, you are going to read a string of size n here. So this n referring to the string here. And then another integer k. K is the restriction. For these cows, they stand from 1 through n. So position 1 through n here. Each cow has type either G or H. Each cow G will eat grass G. Each cow H would eat grass H. And they can afford to walk K steps to go to a patch of their grass type. So for example, in this query, each cow does not want to walk at all. So they have to demand, right, a grass G is here. Excuse me. All right, okay. If each cow cannot walk at all, so if this cow G is here, right, she needs a grass G here. This cow H, she needs a cow H here. So that means, right, every cow would need a grass of the respective type. So to avoid confusion, I'm going to use a grass G, I'm going to put a 0. Grass H, I'm going to put a 1. So now the string you can read, right, that would be the G, H, H, G, and G. So we're going to plant the grass. So grass 0 here, grass 1, grass 1, grass 0, grass 0. So that is why you have to plant the grass like this. So that would be easy, right? When K is 0, it will just be the same. The output would be the same as the input. Okay. In the second query here, now each cow is willing to walk 1 step to find out a patch of their respective type. So again, so G is here, H, H, G, G. How can we, so this would be 5 here. So how do we plant or decide the grass type? So this cow G is here. She's willing to walk 1 step. I can put the grass here. You said that is kind of unfair. What about the cow H here? Don't worry. We're going to work with the cow G independently from the cow H, and also work with cow H independently. Why? Look at this one here. So if there is cow G here, and she's willing to walk 1 step, I'm going to say at position 2, I'm going to plant the grass 0 here for G. And actually, if this grass can cover this unit, right, can also cover this one. So now this grass 0 can cover the cows at position 1, 2, and 3, as long as these cows are type G. Okay, so now there is no cow G, that's fine. There is no cow G, does not matter. So this cow G here, I would say, okay, I'm going to plant another grass 0 she's willing to walk one step, right? So this is 4, 5. So I'm going to plant a grass 0 at position 5. So G can, this cow G can walk here and get the grass. This cow G, right, is already here, so that's fine. Okay, so we need 2 grass patches of type 0. Now for cow H, this cow H is at a position 2, but only grass 0 for cow G, so she cannot eat the grass 0. So we have to plant grass at here. Okay, so this cow is also willing, it's okay to walk one step, so she can walk up to this location. So she's covered, and this cow H is covered here, right? And also if there's a cow H, it's also covered here. Well, after this one, there's no cow H anymore. So we're going to plant the grass 0, 1, and 0. And for those we did not specify, then this will be specified as dot, as we see here, right? So for the second one, you can put grass G here, H dot and G. That's what we have here. So this actually gives us a solution to solve the question. We're going to process the cows G independently and process the cow H also independently. Okay, why that's the case? So here's the argument. Suppose I have a cow G here. She's willing to walk K steps. So suppose this is at position I can plant a grass 0 here for cow G. Okay. And then this grass can cover not only for this cow G at position I, can also cover the cow G up to position I plus 2K, right? If there is a cow G here, she is also willing to walk up to K steps to eat the grass here. And do we have an issue? Say, what if I need to plant a grass 1 here or H so that the cows of type H would also enjoy the grass like this? Actually, this is not going to happen. Why? If you say this is at position I plus K, there is cow J. She's willing to walk K steps to reach this one. If this is exactly K steps, then the J and I must be the same. But in the same location, we cannot have 2 types of the cows at each location, right? If I is equal to J here, then if there is cow G here, then there's no cow H. So if you say, right, the first cow, you're going to say plus K and plant the corresponding type grass, then they would never collide because you start from I, start from J, they would be different. So your location for the grass type 0, grass type 1, they would not be planted at the same location. So this is like, you're going to cover. So we just cover the G here, cow G's, and that's cow H. So when we consider the cow G, you're going to consider the intervals that will cover all the G's. So suppose that's the first G, you're going to use an interval to cover the G's start from this position to the as far as possible. So this will be I plus 2K. So all the cow G's in this interval, right, will be covered by this grass at position I plus K. Now, suppose you have another one. So this is a I prime position. And this one, this location, right, also has cow G. This one, if I prime is bigger than I plus 2K, then she cannot go to this location because this will take more than K steps. Then we're going to say, hey, let's build another interval. So we're going to have the intervals of length 2K. Each interval has length 2K exactly to cover all the cow G's. and it's guaranteed these intervals. So of length 2k for cow G and for cow H, these intervals, they never collide. Why? Because your starting point is different, right? Cow G and cow H, they would never start at the same location. Then the middle of the interval also would be different. That's why we're going to start, say, the G counts, just considering the cow Gs, and find out how many such intervals we need to cover all the Gs. And then we consider the cow Hs, right? Find out how many intervals we need, how many intervals of length 2k are necessary to cover all the cow H, and then just count the number of intervals from cow G and the number of intervals for cow H, add them together, that's the answer. But there's a tiny issue. The issue is if this goes to, say, this is n here, right? You start from 1 all the way to n, and also here you start from 1 and all the way through n here. What if this one is bigger than n, right? You have this interval of length 2k here, you start from here, and you cannot plant the grass beyond the position n, right? What if the center of the interval is bigger than n? How can we do it? This also is a possible issue, right? What if this one is also bigger than the middle of the interval is bigger than n? Okay, if that's the case, we can take this approach, right? If this last interval, this must be the last interval, right, to cover the cow Gs, then you're going to say, okay, I'm going to build the interval. The center is now at n, so the grass 0 is planted at position n. Okay, next time, if we work with the cow H, and can we put this the type 1 also at position n? That's grass 1 for cow H, right? Grass 1 for cow H. If this one is already taken, then you cannot plant 2 types of the grass at the same location. That is not allowed. So that could be the only dilemma we might have using this approach. But think about it. Actually, this is not going to hurt us. Why? So think about it. If k is 0, 2 cases, right? So if k is 0, then if you think about this, put a grass 0 for cow G, then this location must be cow G. This would not be a cow G, then you don't need to worry about this. So we have done the case when k is 0, then you don't have to worry about it, right? Every cow would demand a grass type at its own location. Okay, so now if k is bigger than 0, and you're going to go from this, maybe some I here, right? Going from I plus k to reach this n here. Then you did not plant a grass at n minus 1. Even you start from I, that's n minus 1, but you have planted the grass at position n, so at position n minus 1, you did not plant grass 0. Then in this case, right, you say if position n has been taken, we have used position n to plant grass 0, then you can choose position n minus 1 to use for grass type 1. So it's always possible. You can use either position n or position n minus 1 to resolve the issues. Okay, that is the case for the possible collision of the 2 intervals that may go beyond the position n. But as we just analyzed, right, so it's possible to just have enough space for the type 0 grass and a type 1 grass. All right, okay, so we're going to work with cow G's first, and then work cow H next. And then just for each one, count how many intervals we need and add them together. That's the answer for the question. And of course, right, that'll be easy. Every time if you say for cow G, right, remember the locations for your center of the interval. So you can have cow G, grass 0 here, grass 0 here, grass 0 here, and also grass 1 here, grass 1 here. And for all those other locations we did not plant grass, we're going to leave them as dots. Okay, so again, let me go through one implementation. So here, the feeding for each query, and that's the length of the string we're going to read. K is the number of steps the cows are willing to walk, and we're going to read the string. And this is the answer. We're going to plant the grass. And here I want to use it A specified as 1 for cow grass G, and 2 for 2, that would be grass H. And then later, right, I can remember, do I display a dot if it's 0? 1 display grass G, 2 display grass H. So here, that's the answer for the n locations. Do we need to plant grass there, or what type of grass? And here we're going to remember whether each cow has been covered. Visited means whether the cow has been covered, because right, whenever we work with one interval, it will cover more, possibly more than one cow in the interval. So first we're going to process the cow G's. This part, process the cow G's. We're going to run a loop. I start from 0 and find out the first cow G. If this one is not G, forget about it. If this cow position, right, the position has been covered, also forget about it. Just move on to the next position and continue, skip the rest. Now, if position I is the first cow G that has not been covered, now we're going to find out an interval to cover this cow I. So now if I plus K is less than N, so we can put a grass G at this position I plus K. Now do so, and also going from I to I plus 2K, and make sure, right, this one is no more than N minus 1. Oh, here we have used 0 indexed rather than 1 indexed. So take the minimum of the 2 quantities. So this is the coverage of this current interval going from I to this quantity here. So every cow I in this range, right? If this position J has a cow G, then we're going to say, hey, this one has been covered. And now we're going to move on to the next position. I would take I plus 2K plus 1. You say this may go beyond N. If that's the case, then this loop will stop. Okay. If this is the case, right, I plus K less than N, you can still put the grass at this location. Otherwise, if this one is bigger than N, then we're going to put the grass G at position N minus 1, the last possible location. The same thing, make sure all the cow G's in this interval will be covered. Visited, it's set to be true, and make I to be N so that next time will break. So this part we have processed all the G cows, and then we're going to process the H cows, and you see, right, they'll be independent. So this part would be roughly the same as we did for the G cows, roughly the same idea, but this one a little bit different, right? If this AN minus 1 is available, then we're going to say this location would be put for a GH grass. Otherwise, we're going to take N minus 2. As we just explained, this is possible. And we're going to put a grass H here at this location X here. And then make sure all the cow H, right, in this interval will be covered, and then move on to the next position. And at the end, we're going to count how many locations AJ have been set to be 1. If it's 1, that's G grass. If it's 2, that's H grass. Anyway, so that's the number of the grass patches we need to plant. And then for each one, we have the record, whether it is grass G or grass H, or if it's empty, then print dot. Okay, one tiny thing here. If you want to print this one using the straightforward, for each one, you're going to have a print statement in Java. This may running too slow. So one solution is you're going to use a string builder. Every time you just append a character to this string build SB here, at the end, just use one command print, or you can use an array list of the vectors, characters, then you can do that one. So make sure you just print out once rather than print n times, because n can go up to 10.5. So this may be an issue. In general, for USACO, the output is quite small, maybe just one number or few integers. So that will not make any difference whether you use the efficient, the string builder, or just say print out system.out print, right, each iteration. But if you have to print 100,000 times, then this will be more efficient. All right, okay. So for this one, the Java, the C++ version is, again, very similar. This one you don't have to for C++. The C out is efficient enough, so you don't have to worry about using the string builder or the buffer string for input and output. Okay, that is for the second question, and we still have time to go through the third one. So the third one, many have said, I had no idea what to do. This is actually a question. Maybe you can put this one in the category of miscellaneous or ad hoc. It does not fall into some obvious categories. So this one, you're given, again, queries. How many queries you have? T here. T for sub test cases, or here I will use for queries. For each query, we're given N and M. N is the length of the testing binary string, and M is how many such strings you have the input and you have the output. Okay, let me double check the message part here. Okay, I would also provide the Google Drive link for the files. So later, you're going to receive an email with the link to the video files at Zoom Cloud, and also the link to the Google Drive for the files. Right? Don't worry. Okay, let's come back to this one. We have N and M. N is the length of the input strings. So here 1 means you have a binary string of length 1. 2 means you have binary strings of length 2. And here the M is how many you're going to see. So here M is 3, so you see 3 input, output. 4, you have 4 input, output entries. And our job is, can we find out a program consisting only the conditional statements, if, else if, and else, so that it will produce the output for each input. If you can do it, you print okay. If you cannot, then you say lie. Okay, so for this question, actually, it would be make it easier if you say for each the N, actually, and not N, M entries, the input and output, output is always 0 or 1. 0 means false, 1 means true. Or you can maybe the other way, right? 0 is false, 1 is true, that's fine. So for each of the M entries, input, output, suppose you can find out at a position, say I here, if you have a 0 here, the output is always consistent. So when you have 0, this is always 0 or 1. When you have 0, this is 0. When you have 0, this is always 0. If you have such a pattern, so for M entries, if at position I, so this would be the ith bit, of the M entries, right? If the output is consistent, what does it mean? This position, bit I can be used as a prerequisite, right? I can write the program. If the ith bit is 0, then the output is 0 or the output is 1. When I say consistent, when you fix this bit to 0 and then the output is always 0 or always 1. Or you can say when the ith bit is 1, then the output is also consistent, either all ones or all zeros, then this bit I can be used as a prerequisite. Then you can remove all these entries, right? From the M of them, remove these entries. So that is like when we write the program, as we see in the sample here, right? You can always write a condition. If this one is true, then you're going to return this one, right? So that would be good. And then we're going to keep searching because this M may change, right? After you have removed those entries that have consistent output, remove the entries so M will get smaller and smaller. Every time we're going to find out whether a bit is able to help us to find out a consistent pattern and then reduce the entries in the entries, right? Eventually, when all of them is gone, when this M becomes 0, then you know, right, you can write a program to produce the output and you can print out, print OK. If you have checked every bit, you cannot find out the consistent output. That means, right, some zeros, you have the output that is 0 for this bit I here. Some zeros, the output is 1. That means, right, this bit I cannot be used as a definite condition. You have to use other bits to find out the output. If at the end you cannot find any bit I to help you to reduce more and remove entries from the set here, then you know your answer is a lie. So if you do so, then the question actually becomes much easier. So basically, we're going to go through. Let me just go through this one quickly. So for each query here, N is the length for each input string. M is how many entries we're going to check. And valid would be whether this is okay to do it. And we're going to remember all the entries here. So this is a map for every input and what is the output. And this actually can help us to check whether the input is consistent. So sometimes you may have like this one here, 0, the output is 0, 0 output is 1. Or here, right, you say, maybe to have an example here, you don't. So for example, I might have an entry like this one. So 1 0 output is 1, 1 0 output is 0, then you know, right, this is obviously impossible to write a solution, write a program. So the answer must be false. So here, make sure this one is consistent. Now we have, indeed, that's the map, right? A map from the input to output. Okay. If this one is already invalid, then you just say that's a lie and go to the next query. Otherwise, we're going to try to remove entries using any bit. So if the ith bit being 0 has consistent output, then we're going to remove the entries following the pattern. So this one would just say, go through all the entries. If the bit I is 0 and then the output is only 1, there was only one output, right? Can be 1, can be 0, but make sure it is consistent. If that's the case, we're going to remove it. Remove all the entries where the ith bit is 0. Okay, so that's typical removing entries from the map. Okay, otherwise, if this one is possible, continue. Don't have to try it, right? If saying the ith bit being 0 has inconsistent output, now we're going to check if the bit is 1, can be used as such a criterion, right? Has consistent output. So try the same thing here. So this is 0. Now we're going to try if being 1 has consistent output. If that's the case, again, such a hash set, right, has only one element being always 0 or always 1, then that's fine. We're going to do this one, remove those entries where the ith bit is 1. Now, if HM, the map, right, becomes empty, then you know, right, this is true. Valid by default, we're going to set this one to be true here. By default, if there is no evidence, we're going to assume it is true. So if at the end, if this one, you cannot reduce any entry, checking any bit being 0 or being 1, none of them would give us consistent output, then you know this is impossible. Then we're going to print lie when valid is false. So this becomes easier if you realize each bit can be used as a definite prerequisite. But of course, right, if you don't realize this one during the contest, you're going to find out you're stuck. All right, okay. So that is for the 3 problems. And here I want to also bring back. So this is our schedule. Our classes, the introduction, we have the 101A, that's introduction. 101B, that's intermediate for Java. We have changed the times. Used to be the 10 to 12 on Sunday and Saturday and Sunday. We have changed the time so that last semester, if you were in introduction, now you would move on to intermediate. So we're going to move that spot to intermediate. And the same thing for the bronze, silver, and gold classes. So last semester, if you were bronze A, now this time you would be at bronze B. So you're going to take the same time slot. You get the same thing for bronze B. For bronze C, you're going to move on to bronze silver A. So we have also changed the time slot. And now the same as we did last semester. So all the classes for USACO, we're going to offer Java and C++, both. And also another one is here the design. So Java introduction, intermediate, right? So you're going to go higher. And then bronze ABC also would go higher. Silver ABC also would be higher. So that's the ladder. You're going to make the promotion from the levels of bronze classes and silver classes. And also we have set the approximate levels. If you take the contest, for example, right, you want to decide whether you want to choose bronze B or bronze C. So here we have said, if your test score is between say 300 to 500, probably is better to do bronze B. But if you say my score is between 500, 700, right, then you should take bronze C. For those who have not done it before, then of course you're going to choose bronze A. But this is provided, right, you have taken the introduction, either Java or C++. And then the same for silver levels. For gold, actually, we do not have the ladder level because all 3 would be independent: the data structure, the graph theory, and also dynamic programming. So for parents and students, right, who are making plans to do so, so these would go higher and higher, but these, they would be independent. All right, and we also offered the winter camp for bronze and winter camp for silver, you see right here. And in summer camp also, this would be higher. Summer bronze 2 would be higher than bronze 1, silver 2 would be higher than silver 1. But the best way for you to judge which class to choose would be take a contest and see your levels. Then you can decide which one to take, which class to take. All right, we're going to try to make sure the spring semester would be more flexible so that we have decided every time when there is a USACO contest that week, we're going to take it off so that you're going to focus on the contest rather than coming to the class. And for each round, we're going to also provide the review. So hopefully that will help you to gather and reflect what you have done, maybe some strength you need to keep and some weak links, right? You should improve so that you can do better in the next round.